Okay, so today we're going to get into mole ratios. And what a mole ratio is a ratio of the substances consumed and produced in a chemical reaction. So for every reaction, when we write out the balanced equation, the coefficients will tell us kind of the recipe for that reaction. So you can think about a recipe like you would be baking cookies. You have so many eggs, so much flour, so much sugar, all the ingredients, and they will produce a certain amount of dough that then you can use to bake cookies. So if you add more of the ingredients, you'll get more of the product out. If you take away ingredients, you'll get less out. So same thing here. What these coefficients mean is if I take 3 moles of sodium sulfate plus 2 moles of lead 3 nitrate, and I react them together, I'll get 1 mole of lead 3 sulfate out plus 6 moles of sodium nitrate. So 3 moles plus 2 moles will give me 1 mole plus 6 moles of those things. Okay? So what we can do then, if I wanted to know the ratio of the Na2SO4 to lead 3 nitrate, that would be a 3:2 ratio. Or if I wanted to know the sodium sulfate to the lead 3 sulfate, that would be a 3:1 ratio. And so on. So what we can do with that information then is we can do some calculations using going from moles of one substance to moles of another substance using that mole ratio. So let's say I'm starting with 10.5 moles of lead 3 nitrate, right? And I want to know how many moles of sodium nitrate can I make with that many moles of lead 3 nitrate. So first of all, I have to figure out the ratio between these two. So the ratio between this one and this one is a 2:6 ratio, which that can actually be reduced. You don't have to, but that's the same thing as a 1:3 ratio. So here's how you would set up the problem then. 10.5 moles of PbNO33, and then I'm going to set up a fraction problem like we've been doing with moles, and I'm going to put moles of the lead nitrate on the bottom, and then on top is going to be what I'm wanting. So in this case it's moles of the NaNO3. And then I got to look at what number goes with the lead nitrate. That's my 2. Okay, that one goes on the bottom, or you could use the 1 if you want. And then the 6 is going to go on top because that correlates with the sodium nitrate. Okay, 2:6 ratio. So then what I do is take the top numbers, so multiply 10.5 times 6, and then I divide it by the bottom. So it's going to look like, so 10.5 times 6 equals, and then divided by 2. So that gets me 31.5 moles of NaNO3. So what that means is if I use 10.5 moles of this and then I'm going to have extra of this, I'm going to produce 31.5 moles of NaNO3. Okay, so let's try another one. Let's say I have 5.75 moles of sodium sulfate. And I want to know how many moles of sodium nitrate am I going to produce? So now I'm here, this is what I'm starting with, and I'm going to here. So now my ratio is 3 to 6, or same thing as 1 to 2. Okay? So I'm going to set up my problem, 5.75 moles of Na2SO4. And then moles Na2SO4 goes on the bottom. Again, those have to match. My the mole ratio is always wanted over given. So if my given is this, and my wanted is that. So the sodium nitrate goes on top. Okay? And this time I'm going to use the reduced one. So it's going to be 2 for the sodium nitrate because that's the 6 is correlated with that, and the 1 goes on bottom. So now it becomes 5.75 times 2 and then divided by 1. So 5.75 times 2 divided by 1, which is just going to be itself. So that's going to give me 11.5 moles NaNO3. And then again, make sure your number makes sense. So what this ratio here means is however much Na2SO4 I put in, I'm going to double 1 to 2. I'm going to double that of NaNO3. So my answer should be double of 5.75, which in this case 11.5 is that double. Okay. All right, let's do one more. If I have 8.35 moles of lead nitrate, then how many moles of sodium sulfate am I going to be able to react with that? So now I'm going from lead nitrate to sodium sulfate. Okay, so that is a 2 to 3 ratio. Okay, and that one I can't reduce; it's already in its lowest terms. So let's put it into our problem. So 8.35 moles of lead 3 nitrate, and then moles of lead 3 nitrate is going to go on the bottom. Moles of sodium sulfate is going to go on top. So then I look back at my ratio. The 2 is going to go on the bottom because that came from the lead nitrate. And the 3 is going to go on the top because that came from the sodium sulfate. So now I'm going to do my math. I multiply the top and divide by the bottom. So it becomes 8.35 times 3, then divided by 2. I only get 3 sig figs, so it's to be 12.5 moles of Na2SO4. Okay? So that is how you do mole ratios and calculations with mole ratios. Hope this helps. Let me know if you have any questions.